Today we're going to form special right triangles from these two shapes. First of all, what is this complete shape all the way around? It is a square. What we know about squares is they have all equal sides, and these angles are right angles. Now, a triangle that bisects like this means that if this was 90, then each of these angles, if bisected, are half of 90. So this is a 45-degree angle. Obviously, this is 90, which leaves this to be, again, 45. When you create a triangle by dividing a square across the diagonal like this, you create what we could call a 45, 45, 90 triangle named by its angle pattern. "45, 45, 90. Now, when you take an equilateral triangle and divide from the peak down to the bottom at a perpendicular, we have a 90-degree triangle here. These are not equal. We have this and we have this. This looks a little bigger, but how can we figure out what it is exactly? Well, a triangle contains 180 degrees, and we just bisected one of its angles. So if this was, well, how many degrees are each of these? If it's 180 and there's 3 total, each of these is worth 60. So if I cut this in half, each angle, like this one right here, is 30 degrees. 30 plus 90 is 120, leaving me 60 left, if you get kind of where I got all that. So when we cut up a equilateral triangle in half, we create what's called a 90, well, actually we call it a 30, 60, 90 triangle. Now, we can also learn something about their side lengths that we should know. Let's use the Pythagorean theorem. We know that these lengths are the same because of the square that we learned earlier. So let's just put in 1 and find out what the hypotenuse is. 1 squared, Pythagorean theorem, plus 1 squared is, we don't know squared. 1 plus 1 is 2, is x squared. How do we get the squared away? We do this, which leaves us with x is square root of 2. We can't make square root of 2 look much better. So we're just going to leave that as square root of 2. The side length relationships for the 45, 45, 90 triangle are a 1 to 1 to square root of 2 relationship. All right, now let's work a little more with the 30, 60, 90. Again, if these were all the same size, that means this is equal to twice of this, because this is worth this, and I cut it in half. So this is half of that. So if we use 2, let's use 1. Easiest numbers we can come up with. The 2's over here. 1 squared, let's say, is the b. So what's a? We don't know yet. We're figuring out side lengths for a 30, 60, 90 triangle like this one over here. So finish the Pythagorean theorem. A squared plus 1 is 4. Take the 1 away from both sides. A squared is 3. Nice and ugly. A is square root of 3. So this relationship is a 1 square root of 3, 2, sometimes called 1, 2 square root of 3, understanding we just changed the order. 1 square root of 3, 2. Let's use that to help us with this problem. How does this help? The shortest side of this 30, 60, 90 is 5. What are the lengths of the other sides? If this is 5, why is this 5 square root of 3? Because of this relationship we learned about. 30, 60, 90 triangles are always in this relationship, then you can multiply by square root of 3 to always find that height. And then you know that this is just twice of the short side. A traffic sign shaped like an upside down equilateral triangle has sides that are 12 inches long. So 12, 12, and then that leaves me with a 6 and 6 bisected here. 30, 60, 90. What's the area of the whole sign? Okay, they're asking for this. So formula of an area of a triangle is that perpendicular height times the base. So this times this, and then don't forget to divide by 2. Well, we know this is 12. What does that make this? Remember this relationship earlier? 6 square root of 3, because this is the height for this triangle, which is just an upside down version of the 30, 60, 90 triangles we've been doing. So base of 12 times height of 6 square root of 3 divided by 2 equals. Now, it's helpful when we're working with problems with things like square roots of 2, square root of 3, to maybe use the decimal. Square root of 2 is basically 1.41. Square root of 3 is basically 1.73. So let's do 12 times 6 times 1.73. Did I get that number right? Yep. I'm going to need a calculator for that. Six times 1.73 plus, no, times 12 divided by 2. 62.28. Let's see, check the book and see how I did. That would be inches squared because they asked for area. Oh, it's at the top here. Did something wrong here. 1/2 base times height. Oh, I think I found the right answer, but they didn't use the decimal. They just kept it as square root of 3, which means we would go 1/2 times 12 times 6 square root of 3. So 1/2 times 12 is 6, times 6 is 36, times square root of 3 is 3. So whether it's this or this, I'm good with it. And that's the area of this whole thing using the 30, 60, 90 side relationships of 1 square root of 3, 2. Hoping that makes sense. You should do letters D and E, I believe.